So in this question on car braking distance, a car driver sees a dog on the road ahead and has to make an emergency stop. The graph shows how the speed of the car changes with time after the driver first sees the dog. So let's just check the graph. So we can see the speed of the car. We can see the speed of the car at point A is, look closely, but it's 24. And what we can also do is look at other key things on the graph. So point B, let's just look ahead, and then that's 0.7 seconds. And we can also then see that it ends at 4.7 seconds. So we can see the difference between the two is then 4 seconds, 4.7 minus 0.7. So in the next bit, which part of the graph represents the reaction time or thinking time of the driver? Well, that's when you have a constant speed. So that's the point between A and B. So that's the time when they're thinking. So they haven't yet pressed the brake, constant speed or velocity. In the next bit, what is the thinking time of the driver? And that's when it's constant, so that's the 0.7 seconds. So the thinking time would be 0.7 seconds, because at B, they press the brake. Calculate the distance travelled by the car in this thinking time. Well, to find the distance, what you need to do is find the area underneath the graph. And what we can do is we can draw a rectangle, or shade in the rectangle on the graph if you prefer. And that's the point between A and B, and then all the way down. So if we draw that just here, so what we can see is that the height is 24 and the width is our 0.7, and we need to find the area, so 24 times 0.7, and you can put it into a calculator to help if you prefer, but the answer is then 16.8 metres. Then for part C, calculate the distance travelled by the car during braking. So this time it's the other part of the graph, the triangle. So we've pressed the brakes, we're starting to decelerate. So again, we can draw a shape, so a triangle, and the height is still 24, but the width this time is just 4 because it starts at 0.7, it ends at 4.7. So half base times height, the equation for a triangle, so that's then a half times 4 multiplied by 24, and again in a calculator will give you 48 metres. For part D, calculate the acceleration of the car after the brakes are applied. So we're going to need an equation for acceleration, and the equation that you need to remember is acceleration equals change in velocity, the change in speed, end minus beginning, divided by how long it takes, so the time taken. So we know what the change in velocity is because it's 24 down to 0, so the change in velocity is just 24. And the time taken just for the triangle part is 4 seconds, starting at 0.7, ending at 4.7. And then 24 divided by 4 is, of course, 6. Now notice, this is a 4-mark question and there are no units given. So you have to put the units, and of course the units for acceleration, meters per second squared. For part E, the mass of the car is 800 kilograms. Calculate the braking force. Look for clues if you're not sure. We're asked to find the mass, asked to find the force. In the previous bit, we're asked to find the acceleration. So then rack your brains and then think, I know an equation. Force equals mass multiplied by acceleration. Just because it's a braking force, it's still a force. F equals ma. So then the final bit, 800, the mass, multiplied by your previous answer 6, and that gives 4,800 newtons. As ever, if you have any questions, let me know, and don't forget to press subscribe.